All right, so let's get into this question about when the first stars formed. We've got a YouTube transcript from tactique.io and a couple of Wikipedia articles, and there's even like a whole website called When Did the First Stars Form?
Yeah, it's a pretty big question,
Yeah.
right? Like, when did these stars actually ignite? It kind of unlocks the whole evolution of everything.
Yeah, exactly. So we're going to try and get a good picture of how these stars came to be, like how they started from those first tiny bits of matter
Right.
and then became these giants.
Yeah.
We'll even talk about what they left behind.
Yeah, so,
Buckle up.
yeah, get ready for some serious time travel.
Yeah, for sure.
We're talking about a universe that was totally different than what we see now. Like,
Yeah.
a few 100 million years after the Big Bang.
Okay.
No stars. Just these massive clouds of hydrogen and helium.
Okay, wait, no stars, just gas clouds. I'm having a little trouble picturing that.
Yeah, it's kind of hard to imagine, right?
Yeah.
But like all the stuff that makes up stars, planets, us, it all had to come from somewhere.
Right. So it starts with those super basic elements, hydrogen, helium, that were forged in the Big Bang.
Okay. So how do we get from clouds of basic elements to like the brilliant stars we see today? Did they just kind of like light up one day?
Not quite. It's all about gravity.
Gravity.
Even like the tiniest difference in density in these clouds meant that some areas had a slightly stronger gravitational pull.
Okay.
So over millions of years, these denser spots, they pull in more and more matter. It's like a cosmic vacuum cleaner.
So these clumps of matter are getting bigger and bigger.
Exactly, like a snowball.
Like a snowball effect, yeah.
It's not just about size, though.
Yeah.
As they grow, the pressure and the temperature at their core increases.
Yeah.
Like a lot,
Right.
eventually. It gets so intense that hydrogen atoms start fusing together to create helium.
Hold on. Isn't that nuclear fusion?
Mhm.
Like what powers our sun?
You got it. And when that fusion starts, boom, a star is born.
Okay.
It's like a giant cosmic furnace, igniting, releasing just a ton of energy as light and heat. So these first stars, were they anything like the stars we see today?
So imagine a star so massive you could hold like 100 of our suns.
Wow.
And the brightness.
Yeah.
Millions of times stronger. Just illuminating the early universe.
Wow. 100 times the size of our sun. That's
Yeah.
just gigantic.
Yeah.
I can't even imagine.
So they lived fast, and they died young. They burned through their fuel so fast.
Yeah.
And when they died, they went out with a bang.
Yeah.
Ending their lives in these massive supernova explosions.
Supernovae. So they weren't just pretty lights in the sky.
Yeah.
They were like these huge explosions.
Oh, yeah. They were way more than just pretty lights.
Okay.
They were like fundamental to how the universe evolved.
Okay.
They scattered the first heavy elements,
Yeah.
like carbon, oxygen, iron, out into space.
Wait, so you're saying that these first stars actually created the building blocks for everything else? Like for planets? For life?
Exactly. Think of it like this. They were these giant kitchens
Okay.
cooking up the ingredients for everything that came after.
Yeah.
Without them, the universe would be totally different
Yeah.
and probably way less interesting.
So if they were so important, can we actually see them today? Like with a telescope?
Well, not really. They're so far away, and their light has been traveling for so long that they're incredibly faint. Even the James Webb Space Telescope can't directly observe them.
Okay, but wait, hold on. We can learn about a star billions of years old just by studying some faint radio waves. That's kind of like magic.
It's more like being a cosmic detective.
Okay.
We use indirect clues to put the story together.
Yeah.
And one of our best tools is radio astronomy.
Radio astronomy. So we're listening for radio waves instead of looking for light. How does that even work?
So instead of looking directly for light from these stars, radio telescopes can detect faint radio waves that are emitted by hydrogen gas,
Okay.
which was abundant in the early universe.
Yeah.
And these waves carry information about the conditions way back then, including the effects of those first stars.
Okay.
It's kind of like using echoes to map out a hidden cave.
So we're studying the echoes of these stars to learn about them.
Exactly.
That's pretty cool.
And there's this new instrument on the horizon that's going to totally change this field. It's called the Square Kilometre Array.
The SKA.
Yeah.
Tell me more about it.
So the SKA, it's a massive radio telescope that's being built in Australia and South Africa.
Okay.
And it's going to be the most sensitive one ever built.
Wow.
It'll be able to detect even fainter signals from the early universe. Imagine what secrets we'll uncover.
Okay. So does this mean we'll actually be able to see these first stars with the SKA?
Not really see them directly,
Yeah.
but it will be able to pick up on the imprints that they left on the hydrogen gas around them.
Okay.
It's like finding a fingerprint. At a crime scene, we can reconstruct what happened billions of years ago.
So it sounds like we're on the verge of some major breakthroughs in understanding the early universe.
Absolutely. The next decade is going to be huge for exploring the mysteries of the first stars.
That's really cool. So we've been talking about these first stars, but star formation didn't just stop there.
Right.
New stars are still being born today.
You're right. The same processes that created those first stars are still happening, but in a slightly different way.
So these star factors, they're still making new stars today. That's pretty wild.
Huh?
Where do we even find these stellar nurseries? Are they just like floating around randomly in space?
Not exactly random. They're called giant molecular clouds.
Okay.
And they're huge and cold, filled with the same stuff those first stars were made of.
Oh.
Hydrogen, helium, and just a little bit of heavier elements.
So I'm picturing like a giant cosmic dust bunny,
Yeah.
but I'm guessing it's more complicated than that.
Just a little bit.
Yeah.
Inside these clouds, gravity is constantly at work,
Okay.
pulling the gas and dust together into denser and denser clumps.
Right.
And as those clumps collapse under their own weight, they heat up,
Okay.
eventually reaching temperatures high enough to ignite nuclear fusion.
So it's like the universe is constantly recycling, taking these elements and turning them into new stars. That's kind of poetic.
It really is.
Yeah.
And it's not just stars that are born in these clouds. So as the cloud collapses and a star forms at the center, some of the leftover gas and dust,
Yeah.
it flattens out into a disk around the new star.
A disk. So like a cosmic frisbee.
Kind of.
What happens to all that leftover material?
That's where things get really interesting. So within these disks, astronomers call them protoplanetary disks.
Okay.
Dust grains start to collide and stick together.
Yeah.
Over millions of years, these tiny grains grow into larger and larger clumps, eventually forming planets.
Wait, so planets are born from the leftovers of star formation?
Exactly.
That's amazing. So the universe is like really efficient, nothing goes to waste.
Yeah, and the composition of those planets, their atmospheres, their potential for life, it all goes back to that original molecular cloud.
So by studying star formation, we're not just learning about stars, but also the origins of planetary systems. Maybe even the origins of life.
Right, it's all connected.
That's so cool. And what's even cooler is that we can actually see this happening.
Yeah.
Astronomers can use telescopes to look into these stellar nurseries
Mm,
and watch as new stars and planets are formed.
it's amazing.
That's mind-blowing. So let's go back to those first stars for a second.
Yeah.
You mentioned we can't directly observe them. How do we know so much about them? Are we just making educated guesses?
No,
Yeah.
not at all. We have a few tools to help us. One is computer modeling.
Okay.
We take what we know about physics, like gravity, nuclear fusion, thermodynamics,
Right.
and create simulations of how stars might have formed in those early conditions.
So we're building virtual universes inside computers.
Pretty much, yeah.
Yeah.
We can adjust the starting conditions, like the amount of hydrogen, helium, the temperature, the
Okay.
density, and see how things turn out. It's like a giant cosmic experiment.
But how do we know if those models are accurate?
Yeah.
What if our virtual universe is completely different from the real one?
That's where those indirect observations come in. We compare the predictions of our models.
Okay.
Things like the abundance of certain elements or the fingerprints that those first stars left on the cosmic microwave background radiation.
Right.
We compare that to actual observations.
So it's like this back and forth. We
Right.
refine our models based on new data and then use the models to help guide our observations.
Exactly. And each new piece of data gets us closer to understanding those first stars
Yeah.
and how they change the universe.
This has been amazing. We've gone from the Big Bang to star formation to the birth of planets.
Yeah, it really puts things into perspective.
Yeah.
The universe is always changing, and we're just starting to figure out its story.
Yeah, and to think it all started with those first stars, those giants blazing through space,
Right.
living fast, dying young,
Mhm.
leaving behind the stuff that made everything we see today.
And their story isn't over yet.
Mm-hmm.
Even though those first stars are long gone,
Mm-hmm.
their remnants are still out there.
Okay, now this is where things get interesting. You're talking about neutron stars and black holes, right?
Exactly. Neutron stars are so dense.
Yeah.
Like, imagine squeezing our sun into
Mhm.
something the size of a city.
Wow.
And they spin so fast,
Yeah.
emitting beams of radiation, like cosmic lighthouses.
And black holes. They're like the biggest mystery in the universe, right? Places where gravity is so strong that nothing can escape. Not even light.
It's hard to even imagine.
Yeah.
But they're out there.
Mm.
And some of them, the supermassive black holes at the centers of galaxies, they might be remnants of those first stars.
So even though we can't see those first stars, we can study what they left behind. These crazy objects that break the laws of physics.
It's like a window into the past,
Yeah.
a time when the universe was young and wild. Who knows what secrets those remnants hold?
It makes you wonder what else is out there, just waiting to be discovered. What new mysteries will we find in the next decade, the next century?
That's the beauty of science, right?
Yeah.
The constant search for knowledge, the drive to explore the unknown. There's always something new to learn,
Mm.
always another question to ask.
Well, you've given me, and I'm sure our listeners too, a lot to think about to wrap things up.
Yeah.
Those first stars, they were the pioneers blazing a trail through the early universe, setting the stage for everything that came after.
They were the architects of the universe we see today. And even though they're gone, their story continues to shape our understanding of the cosmos.
And that's a wrap for our deep dive into the first stars. I hope you enjoyed it as much as we did. Keep looking up, and keep those questions coming.